This is just some regular vinegar, and I'm gonna do something that I think is pretty fun. To get started, I just need to dump it into a large beaker, and I'll add about 2 liters. Then into this, I'll add some regular baking soda. This reacts almost immediately with the vinegar, which is acetic acid, and it turns it into sodium acetate. Okay, so now, with all the baking soda added, I can turn on the stirring. I'll also turn on the hot plate, and I'll heat this whole thing up until it's almost boiling. What I'm trying to do now is get rid of pretty much all the water. It was hard to see, but there was a very thin film of crust forming on the surface, which told me that there was very little water left. So now, all I have to do is add a small amount of vinegar, and I can finally take it off the hot plate. Then, what I have to do next is just pour it all into a smaller beaker, loosely cover the top, and wait for it to cool down. After waiting about an hour, it eventually got close to room temperature, and at this point, it should be good to go. So now, it's finally time for the fun part, and all I need is this small crystal of sodium acetate and to pour my liquid onto it. Almost immediately, it starts freezing, and it kind of looks like it's turning into ice. Then, if I keep pouring more, it continues to freeze, and it slowly starts looking more like a bunch of wax. It's all actually just sodium acetate, though, and this is happening because the solution is super saturated. There's way more sodium acetate dissolved into it than it can normally hold, so the moment that it touches the solid sodium acetate, it all quickly crystallizes out. As this happens, it also generates a lot of heat, and this is why it's commonly used to make things like instant hot packs. What I think is interesting, though, is that it's completely solid, and there's pretty much no water left. It's now just a bunch of solid crystals, and I think that's pretty cool.
Sodium polyacrylate is often sold as instant snow, and it's able to absorb up to 800 times its own weight in water. Due to this very useful property, it has a multitude of applications. Its most notable use is in baby diapers as the absorbent. This polymer absorbs water by the process of osmosis. In this case, osmotic pressure arises because there are many more sodium ions inside the polymer than there is in the water that is added. The polymer network forms a semi-permeable membrane, which allows water molecules to enter, but no sodium molecules to leave. Water, by osmotic pressure, is pushed inside the polymer to try to equilibrate the concentration of the sodium ions inside and outside. The influx of water into the polymer causes it to swell. Because electrolyte concentrations of the water will affect the osmotic pressure, it can absorb 800 times its weight in distilled water, but only up to 300 times its own weight in tap water. This is because tap water actually has a significant ion concentration. After absorbing some water, it is a little cold but still dry to the touch.
For a while now, I've been wanting to do something weird with an egg. All I'm going to do is put it into a beaker and add some vinegar. Almost immediately, some bubbles start forming, and this is because the acetic acid in the vinegar is reacting with the calcium carbonate that's in the shell. It's slowly turning it into calcium acetate, which should dissolve into the water. This is going to take a while, though, and I'll leave it here for a couple days. At this point, it looks like it has gotten bigger, and it's also yellow. I think it's ready, and I'll get rid of all the vinegar. Now, what I'm left with doesn't at all feel like an egg anymore. It's kind of just a firm, but squishy sack. It's only being held together by the soft membrane that's normally under the shell, and it's quite fragile. Today, I've decided to do something which I think kind of looks like magic. To get started, the first thing I'll need is solution A, which contains sulfuric acid and potassium iodate. The next thing I'll need to find is solution B, which has starch, malonic acid, and manganese sulfate. The last is solution C, and this one just has hydrogen peroxide. Now, all I need to do is combine them together in roughly equal amounts. The moment solution C is added, it starts changing colors, and then suddenly, it turns almost black. The really cool part, though, is that it doesn't stay that way. It then somehow goes back to how it was, and the cycle starts all over again. This is known as the Briggs-Rauscher reaction, and it's one of the very few oscillating chemical reactions.